Hi everyone and welcome back to PrepFusion. I'm Anish and today we will start with a new chapter that is two-port networks, and this will be the last chapter of network analysis. So we have learned a lot of things in network theory, and this will be your basic building block for all the next chapters. So that's why we have learned everything from basics, and obviously we have done the complex topics as well. So first we will discuss what are two-port networks and what are the different parameters. So I think you already have a bit of idea, but still we will start with the basics. So before starting ports, right, we have to first understand what are terminals. So in network analysis, terminals are physical points where circuit elements or components are connected. Okay, so basically you say gate terminal, you say source terminal. So where the other elements are connected to this particular element, right, are known as terminals. You connect the points: gate terminal, source terminal, drain terminal. So these are all my terminals. In terminals, basically the input and output are not fixed. Okay, so like this gate can act as input, this source can act as output, this drain can act as output. So these are not fixed. So these are generally called as terminals. These serve as entry or exit points for the electrical signals, making them essential for analyzing electrical circuits. So like this is how we analyze. So input terminals where the electrical signal or the power is applied to the circuit. So generally the gate for a MOSFET, the gate is the input generally. Example, like other than this, right, example is voltage source terminal. Okay, where we apply the voltage to some other circuit elements. Then output terminals where the desired output signal is to be connected. That is where the load, generally we connect the load. It acts as a common source configuration. So basically this source is common between input and output, where the drain is connected at the output and the gate is connected at the input. Okay, so yeah, example like output terminals may be the load register where the loads are connected. Common ground, so generally, right, there is a common point between the output and input, which is zero potential point. So those are known as common ground terminal or zero potential terminals. Okay, so generally we make the source to be ground generally in our MOSFETs, if you have studied, right? Or like if I have a voltage source here, simple voltage source. So this will be the this will be the input terminals where I will connect the inputs. Okay, and I have a load here. Okay, so this is the input terminal, this is the output terminal, and this is the common point, right? This is the common point between the input and output, which is grounded. Okay, so these are the terminals basically. So now let's discuss about the what do you call about the ports. So how are terminals defined in ports? So in ports, a two-port network is an electrical network with two-port terminals, port 1 and port 2, where basically the input and output are fixed. So each port consists of two terminals. So this is a single terminal. So I will have a where is the two-port network? So yeah, if I copy this network, right, a network overall will have two ports. This will be my port 1. So here I will have port current as V1 and I1. So this is my port 1, and here is the terminal. Okay, this is the port 2 basically. This is the port 2. So a two-port device, a port has two terminals. One is the input port and output port. So there are two input terminals, two output terminals. Each port consists of two terminals, one for the current to enter and another one for the current to leave. Like each port, right, has two terminals. So through here the current will enter. So here current enters. So every port will have two terminals. Through a single terminal, current will enter and the same current will exit from the other terminal. From here the current will exit. So that is what a port means. So a single port has two terminals, and we discuss about two port networks where a network will have two ports. So we will discuss about that, but for now let's understand what is port. Port basically consists of two terminals. One of the terminals current will enter, and through the other terminal current will exit. That's it. Key point: port terminal 1 is the positive input, terminal 2 is the negative, or generally it is reference ground. And in port 2, the terminal 3, this is the terminal 3 basically, T3, this is T4, this is T1, this is T2. So terminal 3 is the positive input and terminal 4 is the output. Okay, so conditions for a port: the current entering one terminal must leave the other terminal of the same port. So if I say that these two terminals are of the same port, then you have to prove it that if this current is entering I1, then the same current should exit from the other end. Okay, then only it will be assumed as a port, as a single port, else it will not be assumed as a single port. So the condition for two terminals to be in the same port is that whatever current goes in must come out. Whatever current goes in must come out of the port. The voltage between the two terminals of a port represents the port voltage. The voltage between two terminals of a port represents the port voltage. So voltage between the terminals of a port is represented by the port voltage. So V1 is the port voltage of port 1, V2 is the port voltage of port 2. Okay, so these are the few things about ports. So same thing here we have written: a port consists of a pair of terminals through which current enters and exits. The net current entering a port is always 0, because port is a combination of two terminals. So whatever current is entering, same current is exiting, right? So overall current entered in this network is 0 only. Okay. Examples of one port network: like resistor is a one port network because I need two terminals to represent a resistor. Again, inductor, capacitor, all these are one port network. This any linear network will be a one port network, and obviously we will see about two port networks as well. So there are many ways to model using two port networks. We'll see that. So now what are two port networks? A two port networks is an electrical circuit with two separate ports. So single port you have already learned. So two port will have two separate ports, one for input, one for output, used to connect different pairs of electrical system. Each port consists of a pair of terminals where current can enter or leave the terminal. This we have already discussed. Basically, two port network will consist of two ports. Representation of two port networks: so B1 is the input port voltage, I1 is the input port current, V2 is the output port voltage, I2 is the output port current. Okay, to describe the network, two of these four quantities are considered independent. To describe the network, two of these four quantities are considered independent, while the other two are expressed in terms of the independent voltage. Okay, so to describe the network, two of these quantities are considered independent, while the other two are expressed in terms of independent variables. Okay, so these are basically like how can I describe a network? So a network can be described with the help of these four variables. So the characteristics of this network, whole network, can be described with the help of these four variables. So what we do, generally we try to define two values as a function of the other two values. So that is what is written over here. So I have four quantities. What are the quantities? So I have V1, I1, V2, I2. Okay, so I have four quantities. So if I have four quantities, what we do is we write two quantities in terms of the other two quantities. So V1, let's say, is a function of I1, I2, and V2 is a function of I1, I2. Okay, so now what we can say is, like, how can you define it basically? So any network can be defined like this, any two port network. Okay, so if I know this values, right, so basically V1 will be equals to some constant A into I1 plus some constant b into I2 or x, let me write it x into y, there will be a bit of confusion else, or V2 will be equal to some w into I1 plus some z into I2. Okay, so basically, right, if I know this a, b, x, y, w, z, then I know the whole characteristics of the linear network. Okay, I can find out this V1, V2 easily. Okay, so we basically do this. So basically, to characterize a two-port network, we relate the terminal conditions. So I will write here to characterize any two-port network, any two-port network, we relate the terminal commodities. Okay, so basically any of two will be independent of each other and the other two will be dependent on those two independent variable. So basically, how many ways we can choose any two variables out of total 4 variables. So I have 4 variables, I want to choose any two variables to characterize my two-port network. So it is 4C2, so it will be 4 into 3 divided by 2, so it will be equals to 6. So there will be total 6 number of parameters, 6 number of types of parameters through which I can define my two-port network, through which I can define two-port networks. Okay, so basically, like this is the important point that you need to keep in mind. So we will have total 6 kind of parameters. Okay, so total we will have 6 kind of parameters. So few important importance of two-port networks. So this is the first one. Simplification allows complex networks to be analyzed with very lower computations. We'll see, obviously we'll see. We can model the electronic devices. You will study in analog circuits that how we model the BJT. So those things are easier for analysis purpose. We can cascade two different networks and ultimately find out the resultant output of the resultant network. So we will see cascading of networks as well. Filter design is also very easy. So these are the applications, you can go through this. Another important point to note is that if I have a network like this, okay, there is a huge like confusion between the students that what is the voltage drop across this resistor. So voltage drop across the resistor, you will say it has some current IL, load current. So voltage drop VL equals to, this is my voltage, that is V2, port voltage, equals to V2 equals to IL into 5 IL. Okay, equals to 5 IL. So this is the port voltage basically. Now next thing is, what is the, is this correct, is this correct, this is correct, this is my load current, but what is the V2 in terms of I2? So I2, right, is in the opposite direction of IL. So IL is equals to minus of I2. Why? Because I2 and IL are in the opposite direction. So I2 and IL are in the opposite direction. So I can directly write that this will be equals to 5 minus of I2. Okay, so this will be minus 5 I2. Okay, so this doubt should be totally clear, right? When I will write minus 5 I2, when I will write 5 IL, please keep this in mind. IL is opposite to I2. I2 is the port current, so I2 is the port current these things are different. Okay, port current is a different thing and IL is a load current. Okay, so load current will be always going into the positive terminal, right, as it is absorbing the power, but port current is a different thing. It is just a port current of the network, so that is a different thing. Okay, keep this in mind. So this is the load current, this is the port current. So I hope this thing is pretty much cleared. Now let's come to the types of two port parameters. So I told you, right, total we will have 6 types. So these are the types. So today we will basically study about impedance parameters. Slowly we will learn about all the other parameters as well. You don't have to worry at all. You don't have to worry at all. Okay. So what are the Z parameters basically? Z parameters are expressed in terms of the voltage. The first equation that I wrote. So you can express the voltages of the port as a linear combination of the currents. So that is what Z parameters are. Z parameters relate the input and output voltages of the network to the input and output current. Okay, Z parameters relate the input and output voltages of the network to the input and output currents. So V1 can be written as Z11 I1 plus Z12 I2. V2 can be written as Z21 I1 plus Z22 I2. Basically, these are all constants, right? These are all constants, and just like I written over there, X, Y, WZ, these are just X, Y, WZ, but they have some significance, they have some meaning. The naming scheme is given here because they have some significance that obviously we will discuss. So what is Z11? So this is the normal equation format, this is the equation format. Okay, and this is the matrix format. So in matrix, V1, V2 can be written as a matrix formation of Z11, Z12, Z21, Z22, okay, into I1, I2 equals to Z into I1, I2. Okay, so in matrix format you can write your voltages and currents like this. Okay, now what else can you do? So what are the individual meanings of these terms? What are the individual meanings of this term? So Z11 equals to input impedance with the output port open circuited. Z12 equals to transfer impedance from port 1 to port 2. So what is Z11 is the input impedance with output port open circuited. What does it mean basically? This basically means if you make I2 equal to 0, then this equation will be converted as V1 by I1 equals to Z11. So I will explain. So where is the network? So this two port network, yeah, two port network, if I can copy. I have this network, right? So for the case 1, okay, let's solve each one by one slowly. So the equation 1 is V1 equals to Z11 I1 plus Z12 I2. So I need the value of Z11. How do I find out the value of Z11? I don't know about I2. So what I will try to do is I don't know about Z12, right? So I will try to make I2 0. So if it is 0, right, this term is gone. So basically if I make I2 equal to 0, the equation will be V1 will be equals to Z11 I1. So Z11 will be equals to V1 by I1 when I2 is 0. This is a very important condition, right? So I will be able to write it is ratio of V1 and I1 only if I make I2 0. Okay, so I have to make this port current 0. Basically what I have to do is I should not connect any load here. I should keep it open. And what should I do? I should either apply a voltage here. So I will apply a voltage here and then measure the current through this voltmeter. I will connect an ammeter, I will measure the current, then I will take the ratio of the voltage and current. That will give me the parameter named as Z11. And as it is on the input port and we are taking the ratio of the input voltage and the input current, that's why it is called as input impedance. So that is the reason why it is called as input impedance. What about this? Let's do this first. Okay, Z21. So for Z21 as well, what is the equation for Z21? The equation for Z21 V2 is equals to Z21 I1 plus Z12 Z22 I2. Okay, so this is what my V2 is equals to. So V2 is equals to this. So again I want to find Z21. So what do I need to do? I need to make this somehow 0, right? Then only I will be able to find Z21. So I will make I2 0. Again I will make I2 0. If I make I2 0, so my so my V2 equals to V1 will be equals to I2 by V2 by I1, that is equals to Z21. Okay, so that is what my Z21 is equals to. So I hope you have understood this very basic thing, very basic point. So this is equals to my Z21, but remember this is equals to what? This is in the period when my I2 is 0. Again, this time what I will do is I will again force a voltage here, but I will not measure the current through the ammeter, right? So previously I was measuring the current through the ammeter here. So I had a ammeter connected here. Okay, so this is the ammeter that is connected here. So now what I will do, I will not measure the current, I will measure the voltage in the output port. Still of course the output port is still open circuited. Output port is still open circuited, that is fine, output port is open circuited, but this time, right, I will connect a voltmeter, and I hope you remember that voltmeter has infinite input impedance, right? No current will flow through the voltmeter. So now I will measure the voltage. So voltage I will measure right now. So this is the measuring point, and like of course I have given some input voltage, I don't care. So again, right, but this has a condition, no load should be connected, right? No load should be connected. So that's why I2 has to be 0. Another point is, why is it called transfer impedance here? It is called transfer impedance. First of all, it is a ratio of voltage and current. So anything that is a ratio of voltage and current, its unit will be in impedance only. Why is it called transfer impedance? Because I am taking the ratio of voltage of port 2 to current of port 1. It is transferring, right? That's why it is known as, from one port to other port I am taking the ratio, that's why it is transfer impedance. Same in case of Z12 as well, as I am taking the ratio of V1 voltage 1 and the and the current of port 2, that's why it is known as transfer impedance. Transfer means from it is they are of two different ports, so that two different quantities are of two different ports, they are not in the same port, that's why transfer. So I hope you can understand this second equation as well, not second, this part as well. What you have to do, same thing, you have to make I1 0. If you make I1 0, you will get V1 by I2, that will be the Z12, known as the transfer impedance, when my input current is 0. So basically you will what you will do is, you will this time connect a voltmeter here and connect a voltage source here. That is your task. So you will connect a voltmeter here and connect a voltage source here, and you will just measure the current. So that will give you the that will give you the this Z12. Same thing, right? Same thing you can follow. I hope you get, right? I hope you get it. So okay, let's do it anyways. Let's, for the first one, let's do from scratch. So in the other equation, I have this, right? V1 equals to Z11 I1 plus Z12 I2. So what we do this time, I need to find this ratio Z12. So what I will do is, I will make I1 0. So if I make I1 0, so this time my V1 will be equals to Z12 I2, or my Z12 will be equals to I1 by I2. Okay, so this is what my Z12 can be equals to. Now what you can do is, you can do one thing. You can this is when my I1 equals to 0. So again I will copy the network, and this time, right, the voltage source will be applied in the port 2, not in the port 1. Voltage source will be applied in the port 2. So if I apply a voltage in the port 2, so I will apply a voltage in the port 2. Okay, and this is the what I have to measure. I have to measure the current in the port 2. So I will connect a ammeter here in the port 2, and I have to measure the voltage in the port 1. So I will connect a voltmeter. It is open circuited. Port 1 is open circuited. That is fine. But of course I can connect a voltmeter, right, to measure the voltage across the port 1. So this is my configuration for this case. So what about the other case? What about the last case? So in the last case, the equation is I have to find out Z22, right? So equation is V2 equals to Z21 I1 plus Z22 I2. So again I have to find out the value of Z22 because Z21 I have already found out. Okay, so what you can do is you can basically make the input current 0. If I make the input current 0, it will be the Z22 will be the ratio of V2 by I2. Z22 will be the ratio of V2 by I2 when my input current I1 is 0. So now I have to measure, I have given the input voltage. Okay, fine. I have to measure the current only. I don't have to measure anything. I just have to measure the current. That's it. So with this arrangement only, the two parameters can be found out, and with this arrangement only the other two, not this, right? If I have an ammeter connected here as well, so basically, right, I don't even need this. Just if I just connect a voltmeter here, that should be enough, right? So if I connect a voltmeter in the output, for I am talking about Z12 and Z21, sorry, Z12 and Z11. For that arrangement only I need a ammeter. What things I need? I need the network, obviously. I need the ammeter, I need the voltmeter, and a voltage source. That's it. If I have these four things, then I will be able to find out the Z11 and Z12. Sorry, not Z12, sorry, Z11 and Z21. And to find out the other two parameters, those elements I will need, but I will connect them opposite. Now I will connect the voltage source in the port 2, I will connect the ammeter in the port 2, I will connect the voltmeter in the port 1. Here it was just reverse. Okay, so these are also called as open circuit parameters. Open circuit parameters. So why are these called impedance parameters? These are called impedance parameters because of course their units are ohms, right? That's why these are called impedance parameters. Okay, now why are these called open circuit parameters? These are called open circuit parameters. These are called open circuit parameters because I am either the input is open or the output is open. To find out the parameters, either we have to open the input or the output. Open circuit means zero current. Open circuit means zero current, right? I equals to 0. So that is what open circuit means. So that is the reasoning behind this open circuit parameters. So what is the matrix format basically? So the matrix format we have already discussed. If we have found out the equation, matrix format Z is equals to Z11, like I can write in matrix format. This can be written in matrix format. That is my voltage V1 V2 equals to the Z11 Z12 Z21 Z22. And don't worry, how will I remember this, right? These which belongs to which one, I will explain. Don't worry about it, I will explain that. into the currents I1, I2. Okay, so I can simply write this equation as V equals to Z into I, or I into Z, whatever, whichever one you prefer, V Z into I. Okay, so few things you should keep in mind how to find out the inverse of Z parameter matrix, because that will be handy when we will discuss about Y parameters. So what is the inverse? So for to find out the inverse of any matrix, we know it is equals to this basic thing, you know, right? To find out the inverse of any matrix, basic thing is you write the adjoint of that matrix divided by the determinant of that matrix, divided by the determinant delta Z. Okay, so what is adjoint of A? Adjoint of A, right, is very simple. For a 2 cross 2 matrix, the adjoint of a matrix is very simple. Simply what we do, we just swap the main diagonal elements and change the signs of the off diagonal elements. So we will swap the main diagonal elements. So it will be Z11 and this will be minus Z12 yeah, Z11, and this will be minus Z21. Okay, so yeah, these are basically the magnitudes basically. So ultimately what will be your ultimate answer, inverse of Z. So inverse of Z, this is important because this will be my Y parameter, which I will discuss obviously in the next lecture, will be equals to Z22 by delta of Z, right? This is my determinant I have already find out. So Z22 by delta of Z minus of Z12 by delta of Z. This will be Z minus of Z21 by delta of Z into Z11 by delta of Z. Okay, so yeah, these are my Y parameters basically. Now, right, let's come to the measurement. I have already discussed how you can measure the values. So the same thing whatever I have discussed is written over here. So whatever I have explained to you is written over here. Now there is a general misconception between students that the Z11 is equivalent to the Thevenin impedance. But no, Thevenin impedance is an unconditional parameter. What do I mean by unconditional? So this will cross mark. So what do I mean by unconditional? So the Z11, it has a condition attached to it. What is the condition? Condition is the current in the port 2 must be 0. Then only the ratio of V1 and I1 will give me Z11. So the current in port 2 must be 0. So there is a condition. Condition is this one, right? This is the condition. So you have to anyhow make the current in the port to 0. Then only the ratio between the input voltage and the input current will give you as the Z11. Because sometimes you assume that okay, I have given some input voltage and I am measuring the current. So voltage upon current is the ratio of the Thevenin. Generally this is the Thevenin impedance, right? Thevenin impedance that we are used to. No, but this is not the Thevenin impedance. This is the Z11. Okay, that is the input impedance when the output port is open circuited or the port 2 is open circuited. Keep this in mind. Now how to remember the equations. So what is Z11? Z is the impedance parameter. So how do I remember? So first you write the Z. So Z is, by Z we know it is impedance. So this is the first step, right? We know Z is impedance. So if Z is impedance, that means it will be a ratio of voltage by current. I don't care of what voltage and of what current, but definitely it will be a ratio of voltage and current. So first point is established. Now in the secondary point there will be some numbers, right? Z11. So Z11, this one, the first number represents the number of the voltage. Okay, so this will be the V1, and the second number represents the number of the current, that is I1. Okay, so now I hope you understood that. Okay, I have to measure the voltage of port 1 and the measure the current of port 2. Now as this is a Z parameter, and I have told you Z parameter means open circuit parameters. Z parameters means open circuit Z parameters means open circuit parameter. So keep this in your head. We have to make some current 0. So always there will be some condition, some current will be 0. So now I know Z11 is the ratio of V1 by I1. Can you make I1 0? If I make I1 0, will I be able to find out this Z11 value? No. It will go towards infinity, right? So of course I cannot make I1 0. So what kind of current is left? Only one current is left, that is I2. So of course from there, in the third step, you remember that already I1 is there in the denominator. I cannot make I1 0. I have to make I2 0. So already I1 is there in the denominator. So Z11 will be equals to V1 by I1. I1 is already there in the denominator. So I will make I2 equal to 0. Okay. So this is the case. This is the case basically. So now I hope you can repeat the same exercise for all the other three parameters. Repeat the same exercise for all the other three parameters, and you will observe that you are able to remember. You don't need to remember, just understand the method. How am I writing it? Okay, and this method will be used in the other parameters as well. I will explain there as well. Okay, so yeah, one important point you have to keep in mind is Z parameters only exist if I1 and I2 are independent of each other. Okay, if I1 and I2 are dependent of each other, then you will not be able to find out the Z parameter. So this will be a very, very important point that I will prove it to you. Okay, once I will give you a few homeworks, and on the next lecture I will prove it to you why is that the case. So basically if I1 solely depends on I2, or I2 solely depends on I1, Z parameters are not defined, cannot be defined. Okay, so why is that the case? So what are my equations? So my equation is V1 equals to Z11 I1 plus Z12 I2. So if you say my I1 is some combination of I2, right? I1 is some x of I2. Okay, so your equation will get converted like this. V1 will be equals to Z11 x of I2, or this will be Z11 x of I2 plus Z12 into I2. So your V1 will be equals to Z11 x plus Z12 into I2. So you have how many unknowns you have? So these many unknowns you have, right? So one equation I have two, like these two unknowns I have, only one equation I know. Okay, x will be some known value, that is fine. So I will never be able to write basically, like either I will never be able to find out Z11 and Z12 separately, and it will not exist. I will prove it to you as well. Okay, so you just keep this in mind, and once we will go into a few questions there I will explain. So let's solve very, very basic things to how to solve Z parameters, and from there we will go to the difficult and complex problems. Let's copy the network and first write the port voltages and currents. So this is my port 1 and this is my port 2. So I will write the port voltages and currents. So this is V1, I1, this is I2, this is V2. Okay, so here so there are two ways to go about it. So method 1, is the slower method, which I will never recommend you to solve, but of course you can solve as well. So method 1, right, use this method, use this when you have to find only one parameter. One parameter. So method 1 is this one, right, where you have to find only one parameter. So what do I mean by it? I will explain. So let's first find each parameter one by one. So let's say I am finding out z11, z11. So what is z11? Z11 is v1 by I1 when my I2 is 0. Okay, I hope you understand the flow. Z means voltage by current. 1 is this for this numerator, this one is for the denominator, and of course I have made here I1. So of course I cannot make I1 equal to 0, I have to make I2 equal to 0. So I have to make I2 equal to 0. That means what? That means this will be open circuited. So this is open circuited. So if this is open circuited, whatever, like this current is 0, right? This current is 0. So the same current will flow through here. So what I will do, I will just first copy this circuit here. This is the normal standard circuit, and I will redraw this circuit. So here, right, this will be I2 will be 0. So if I2 is 0, same current will flow through here, I1. Okay. So you can say that my Z11 equals to V1 by I1. So what is V1 by I1? Basically, right, these two are in series because same current is flowing through. So V1 is basically equals to 20 plus 40, or you can write the KVL as well, minus V1 plus 20 into I1 plus 40 into I1 equals to 0. So my V1 by I1 will be equals to 60. Okay, so this is what my V1 by I1 is equals to. Okay, so now if you want to find, so when you do this kind of thing, right, so if I am making I2 equal to 0 in the same circuit, let's find out the Z12. Sorry, let's find out the Z21, because that also has a condition of I2 equal to 0. So I don't want to redraw my circuit again. Okay, in the same circuit I want to find out Z21. So what is Z21? It is V2 upon I1 with I2 equal to 0, the same condition. So all of them are same only, I2 is 0. So I need to find out V2. So what will be V2? V2 is the volt, like this is 0 current, right? So there is no current through this 30 ohm resistor. So there is no drop across this 30 ohm resistor. So all of the drop is across the 40 ohm resistor. So my V2 will be equals to, it is simply a voltage divider circuit, right? So it will be 40 V1 into 40 divided by 40 plus 20. So it is equals to 2 by 3 V1. Okay, so this is what my V2 is, but actually I don't need in terms of V1, right? I need V2 by I1 ratio. So what is my V1 in terms of I1? So V1 from this equation, I can say V1 is equals to 60 into I1, correct? So I can replace here V1 60 I1. So V2 will be equals to 2 by 3 into 60 into I1. So V2 will be equals to 40 into I1, or V2 by I1 will be equals to 40 ohms. Keep this in mind. Don't forget that there is a condition. This is conditional parameters. So it is when I2 equals to 0. So one more thing I forgot to mention here, that sometimes these are also called like my 2-port parameters, right? I will write at the starting. So two port parameters are also called called conditional parameters. Why are they conditional? Because either you make some current 0 or you make some voltage 0 for next parameters we will discuss. So you have some condition attached. So like if you are in a relationship, right? So you have some condition that at least for a month we will go out for the movies, or we will meet two times in a month. So there is some condition, right? So it is not unconditional. So it has some conditions. So here also there are some conditions. So if you want to find out the parameters, there are some conditions attached with it. So these are called conditional parameters. Because in this case, what are the conditions? Either I make the I2 current 0 or the I1 current 0. So these are my condition for Z parameter. For other parameters, the conditions are different. Okay. So of course, right, if like for different type of relationships, the conditions are different. So you have your father son relationship, that is a different kind of conditions. There are different kind of conditions. Then you have your like girlfriend or boyfriend relationship. So those are different kind of conditions. Okay. So I hope you understood the point. So let's come to where was I? So yeah, I was here, right? So this is my Z21. Okay, I got my Z21. Now let's solve for the Z12 and Z22. So let's first find out the Z22. So my Z22 is what? Z22 is V2 by I2 when my I1 is equals to 0. So I have to make this current, input current equals to 0. Okay, I have to make this current, input current equals to 0. So I1 is 0, amperes. So I2 will be what? I2 will be what? I2 will be I2 will be some current, right? I have applied some voltage, I2 will be some current. So now very simple, right? Again these two are in series. So of course V2 by I2 will be what? Because none of the current is flowing through here. So whatever current is coming, same current will go through this 40 ohm. So basically these two are in series. So V2 by I2 will be basically 30 plus 40, that is 70 ohms. So V2 by I2 is 70 ohms, that is Z22 is 70 ohms. What about Z12? Z12 is V1 divided by I2 when my I1 is equals to 0. So again the same thing, right? Voltage division. You apply the voltage division basically. So if you apply the voltage division, what you will observe? You will observe that I can write my V1 equals to V1 equals to this, sorry, yeah, V2 into 40 divided by 30 plus 40. So my V2 will be equals to 4 by 7 V2. 4 by 7 V2. Now what is my V2 in terms of I1? Because I need the relationship, sorry, in terms of I2, because I need the relationship between V1 by I2. So my I2, so my I2, right, Z22 is V2 by I2, that is 70. So V2 is equals to 70 into I2. V2 is equals to 70 into I2. So I can write here 4 by 7 into 70 I2. So this will be 40 I2. Okay. So this is what my V1 in terms of I2 will be. So V1 by V1 by I2 will be equals to 40 ohms. Of course, there is a condition. Condition is I1 is 0. Okay. So these are the individual parameters. We have found out all the parameters. So I can finally write my equation. V1 equals to Z11. Z11 was 60 ohms. 60 into I1 plus Z12. Z12 we have just found out, that is 40 into I2, and V2 is equals to Z21. Z21 is Z21 is 740. Okay, Z21 is also 40. 40 into I1 plus Z22 is 70 into I2. Okay, that is what my V1 and Z2 are. So these are my Z parameters. So this was the first method. Second method is, right, when use this method. So I will solve using second method. So use this method when you have to find Z parameters of the whole network. Okay, so basically, right, I have to find all the parameters. So if I have to find all the parameters, so I will use simple KCL and KVL. Okay, I will use simple KCL and KVL. So I will copy the initial network. So here, right, what I will do is I can write, basically I can take a I can write a KVL. I can write a KVL in this loop, and I can write a second KVL. So what is the current through this loop? So this is I1 current, this is I2 current. So this current will be I1 plus I2. This current will be I1 plus I2. So if I write a KVL in this loop 1, this is the loop 2. So KVL in the loop 1, it will be minus of V1 plus 20 into I1 plus what is the current through this branch? I1 plus I2. So it will be 40 into I1 plus I2 equals to 0. Okay. So it will be, so my V1 will be equals to overall 60 into I1 plus 40 into I2. Okay, and what about the other KVL? KVL in the loop 2. So KVL in the loop 2, if I apply the KVL in the loop 2, so it will be minus V2 plus 30 into I2, like drop is like this, right? So plus 30 into I2 plus whatever KVL convention you follow, you can follow your own KVL convention, but at the end you will get the same result. There will not be any difference. At the end you will get the same result. Okay, so this will be plus 30 into I2 plus I1 plus I2 into 40 equals to 0. Okay, so from here you can directly again write what is your V2 in terms of I1 and I2. So V2 is equals to 40 into I1 plus 70 into I2. So like you might say, sir, क्या कर दिया आपने? मतलब you are wasting so much time. You are wasting so much of my time, right? Explaining this. You could have directly shown me this. Why waste the time? So of course, if you know one thing, life is a marathon, not a race. Okay, so these things are also useful. These will be also useful. This network is very simple. So you might feel, okay, this method is so easier. Okay, but when the network will be very complex, at that point of time we might use this one because we might need to only find out one parameter. If you have to find out all the parameters, then you will use this method obviously. Okay, but if you have to only find out one parameter, then it's better to use this one. Now it might seem a task that you wasted so much time, but I found out all the 4 parameters. That's why it took me so much time, right? But if you just find out one parameter, it will not take you much time. But when the network will become more complex, the calculations and KVLs will not be this simple. Trust me. Okay, so of course both methods are important. It's not like that is super, like that you will skip. No, both are important. You have to understand the context when to use which one. Okay, so one more thing, if you notice one more thing, that my Z21 is equals to Z11. Okay. Now this is the condition for a reciprocal network. So we will discuss for what about reciprocal network later on as we move along. So that will come. That thing will come when that reciprocal network will come. I will discuss about that. Okay. For now, I'm ignoring it, ignoring the fact. For now, just understand the condition for a network to be reciprocal is to satisfy this equation, that Z21 will be equals to Z11. So this is the condition for reciprocal network. Reciprocal means the network which obeys the reciprocity theorem. So that is what my reciprocal network means. Okay, the network which obeys the reciprocity theorem. That's it. Okay, so like now I don't recommend you remembering the formulas, but educators teach this, so I also have to teach this, else you guys will shout at me, sir, why didn't you teach it, that guy teached it, right? So uh, there is a formula for star network, so but I will recommend not to remember, but it is intuitive, you can understand this intuitively. So basically, right, what is the formula for star network? So in a star network, right, I only have two KVLs, one is the input KVL, another one is the output KVL. Okay, so in the KVL one, if I write in terms of, like, these are in terms of variables, so I can directly write what is the current through here. Current through here will be I1 plus I2. So my voltage minus V1 plus I1 into Z1 plus I1 plus I2 into Z3, okay, equal to 0. So my V1 will be equals to Z1 plus Z3 into I1 plus Z3 into I2 equal to 0. So not 0, sorry, not 0, equal to this, right? So what is my V2? Again, the output KVL, right? KVL 2. KVL 2. So minus V2 plus Z2 into I2 plus I1 plus I2 into Z3 equal to 0. So my V2 will be equals to, this is I2, right? Yeah, so V2 will be equals to I1 into Z3 plus Z2 plus Z3 into I2. Okay, so from here you can directly write like your Z matrix. What is the Z matrix? Z matrix is this. Z matrix is basically like I can write the Z11. What is Z11? Z11 is this value, right? This is the Z11, correct? Z1 plus Z3, Z12, Z21 and Z22. So this value will be Z3, and you observe, right, your Z12 is equals to Z21, that means it is a reciprocal network. I will discuss about reciprocal network in the Y parameters. So Z22 is equals to Z2 plus Z3. Okay, so yeah, that is the case over here basically. So I hope you have enjoyed this fact. So this was the, like, how can I represent in matrix format? So you can represent in matrix format like this. Your Z parameter will be Z1 plus Z3, Z3 will be here, Z3 will be here, then Z2 plus Z3. So if you want to remember, for the guys who are very sharp in memorizing things, they can remember this for a simple star network, star or Y network. Okay, so this is the formula. So if you want to remember, you can, of course, no need to remember, no pressure, like it will take you hardly 30 seconds to derive to the result, right? So if you know the derivation, it will hardly take you 30 seconds. So few things I wanted to give you as okay, let's solve this. Let's solve this in this lecture only. Or okay, we have few more things as well. So I want you to do try this. I want you to try by yourself, then I will solve this. So find out the z parameters for this network, find out the z parameter for this network if it is modified, and these are all homeworks. So all these are I'm giving you as homeworks, and in the next lecture I will solve all of them. Okay, so yeah, let's okay, not let's solve this one, this pi network. Okay, let's solve it in the next lecture only. Let's solve it all these questions in the next lecture only. So I think that was about it. So we will try to solve all these questions in the next lecture. Okay, so just take a screenshot and try to attempt in the next lecture. Okay, there will be so many questions in the next lecture. That is fine, that's totally fine. I think yeah, this also I will discuss in the next lecture. So for this lecture I think that's enough. So take a screenshot and try all the questions by yourself, and in the next lecture I will solve, of course. Don't take too much pressure, spend around like try thinking. If you are not able to reach to the solution, of course you can go and watch the solutions. Okay, so yeah, that's it from my end. I hope you have enjoyed this lecture, and in the next lecture we will solve all the questions. Until then, happy learning.